right, free response question number 3, the traditional trig looking problem. I've seen a bunch of practice problems that have this picture and involve some type of oscillating figure, like whether it's a Ferris wheel spinning around or a bike pedal spinning around or a metronome going back and forth. In this case, we have a pendulum desk decoration that uses a magnet to keep the weight hanging at the bottom of a string swinging back and forth in all directions. So this was pretty popular when I was a kid way back when. You would get these things that you put a battery in and this thing hangs from the bottom and there's whatever the battery does creates some kind of electromagnetic field where this guy goes back and forth and back and forth and back and forth. So you can kind of assume, all right, well, the back and forth, the back and forth, the back and forth, that's where the waves come from. The weight reaches a maximum height of 3 inches off the desk and a minimum height of 1 inch off the desk. The pendulum sways back and forth, completing 3/4 of a cycle per second. The sinusoidal function h of t can be employed to model the height h with respect to time t. The pendulum weight is at its maximum height at t equals 0 seconds. Okay, so pretty much what we're dealing with is no calculator allowed. All right, if I were to, I'm not even going to draw a sinusoidal function. Draw the picture out. Usually I draw the picture out, but that seems to be done for me. Actually, you know what? The heck, I'm going to do it anyway. Let's take the information that we have and make ourselves a rough draft. Now, obviously, real life stuff, so all in quadrant 1. At the very top, we're at 3. At the very bottom, we're at 1, which puts us at a midline of 2. So right now we could start saying you would be my 3 and you would be my 2 and you would be my 1. Okay. The weight reaches maximum height of 3 and 1 inch off the desk. The pendulum sways back and forth complaining. I'll get there in a second. The sinusoidal function h of t can be okay. So it's at the maximum height at t equals 0 seconds. So it's already up here. Okay, which screams cosine, and this is going to go down and come back up. Okay, now it completes a cycle every 3/4 of a second, which means that's my period right there. Okay, my period is 3/4. Now, I don't know if I'm going to need this. Maybe I will, maybe I won't, but this is what I have already. Okay, I have this already. So the graph displays h and its dashed line midline for 2 complete cycles. Points A, B, C, D, and E are marked on the graph. No scalar axes are provided. Determine the potential coordinates t, h of t for these 5 points A, B, C, D, and E. All right, so right off the bat, we could do A as our maximum. So we could say that A is 0, 3. Okay. So you would be, this is where it gets a little complicated. So 0, 3, that part's pretty easy. B is going to be something 2. I'll get there in a minute. C is going to be something 1. I'll get there in a minute. D is going to be something 2. I'll get there in a minute. And E is going to be 3/4, 3. So that gives me E. Okay. Now, if you're like, whoa, 3/4, where did that come from? It completes a cycle at 3/4, which means the period is 3/4. Did I say 3/4? 3/4. All right, now we're going to have to do a little bit of math. Okay. So everything is going to be based on the fact that we start at 0 and we end at 3/4. So it hits its minimum at half of 3/4. It hits the midline here at 1/4 of 3/4, and it hits the midline again at 3/4 of 3/4. So if you followed what I just did there, B is going to happen at 1/4 of 3/4. Okay, so whatever the distance, this goes from 0 to 3/4. This is going to be 1/4 of it. So 1/4 of 3/4 is 3/16. My favorite Bible verse. So this is going to happen at the x value of 3/16 and a y value, or in our case, t and h of t, of 2. So 3/16 and 2. Now I hit the bottom literally halfway in between 0 and 3/4. So C's x value or t value is going to be half of 3/4. Okay, 1 times 3 is 3, 2 times 4 is 8. So I've got 3/8 1. So C is going to be 3/8 1. Okay. This is going to be 3/4 of the way to 3/4. So D, the t value, is going to be 3/4 of 3/4. 3 times 3 is 9. 4 times 4 is 16. That gives me 9/16, 2. So D is 9/16, 2. Now, the reality is there's an infinite amount of answers here, right? Because if I wanted to be a silly goose and start at 3/4 3, I could have. But I didn't because I'm not insane. So that's why it says potential coordinates. All right, so that's A is coming up with 5 points. Hooray! B is going to ask us to find the function. Oh, and like I said, this screams cos because it is cos. Determine the values of the constants A, B, C, D. Blah, blah. So again, my rough draft, right, had me starting up here at 3, midline at 2, and bottoming out at, well, let me put the dash line here, bottoming out at 1. Okay, we went down, bottomed out, and repeated at 3/4. Now, if you don't remember what means what here, A stands for amplitude, okay? Now, the amplitude is half the distance from the top to the bottom, or it's the distance from the midline to the top. Okay, so the numbers are friendly enough where we could say, oh, okay, well, the amplitude is just 1, and you would be correct. Now, if you had to do some math because the numbers weren't pretty, the way you could find the amplitude is you would do 3 minus 1, the maximum minus the minimum, divide that by 2, and you would just get 1 anyway. Okay, but for this one, it's simple enough. If it's not simple enough, maximum minus minimum, divide by 2, there you have it. B stands for the frequency. Now, the frequency is found by taking 2 pi, because cos's period is 2 pi, and dividing it by the period that you have here, which is 3/4. So frequency is 2 pi over your period. My period is 3/4, so let's multiply the top and the bottom by 4/3, multiply the top and the bottom by 4/3. You cross out, you cross out, you cross out, you cross out. As tempting as it is to look at the 2 and 4 and think something crosses out, it doesn't. So I have 8 pi over 3. So B is going to be 8 pi over 3. Pretty gross, but that's what it is. C is a horizontal shift where you move left or right. Well, since I'm dealing with cosine and regular old cosine looks like this, starting up here and going down there, I have the same exact behavior. So I have no horizontal shift. So my horizontal shift is nothing. Okay, D is going to be my midline or vertical shift. Whenever you think sinusoidal stuff, think midline, and my midline is 2. So if you're thinking, oh no, let's write out the formula and circle that. Don't do that, because they don't want you to write out the formula here. They just want you to figure out what A, B, C, and D are. So let's rewrite those out so they're nice and pretty. A is 1. B is 8 pi over 3. C is 0. D is 2. And that's part B. Part C has us referring to the graph in part A. Great. So I have that back. Let T sub 1 denote the T coordinate of point B. So you are also T sub 1. And T sub 2 denote the T coordinate of C. All right, so that's T sub 2. Within the interval t sub 1, t sub 2, which of the following statements accurately describes h? H is positive and increasing. Okay, so hold on, time out. Let's break this down. Let's remember exactly what we're dealing with because it's giving me options about positive, negative, stuff like that. Remember, this is a pendulum swinging back and forth. Okay, it's up in the air in positive land. Okay, so you're 3, you're 2, you're 1. No matter what happens within this interval, so they're basically saying what's happening between here and here. Well, between here and here, no matter what, we're positive because we're above ground. This is a pendulum swinging in the real world. So we're above ground, and no matter what, it's going to be positive. Okay? Now, what else is going on here? In this case, it's decreasing because it's going down and to the right. So this is positive and decreasing, which gives us B. Pretty simple answer. Okay? Nothing crazy that we have to lose sleep over. Okay? Why they're making us do t sub 1 and t sub 2, I have no clue. Why couldn't they just stick with B and C? I have no clue. I didn't make the problem. Actually, I did. Describe the change in the rate of change of h within the interval t sub 1 and t sub 2. And if you're thinking, rate of change, let's whip this puppy out. Yes, I can do this. Let me get the numbers from the previous thing. If you're thinking that, you're doing it wrong. They are saying the change in the rate of change. What that means is if it's like you're basically saying this is concave up and decreasing. So what you're saying is the change in the rate of change is going to have me describe what decreasing on concave up means. That's what they want. Change of rate of change is something like it's increasing at a decreasing rate, or it's decreasing at a decreasing rate. Whatever going down on concave up means. Concave up means the rate of change is increasing rate. Probably terrible English there. Decreasing at an increase, or whatever at an increasing rate. Okay, so increasing rate. What this is doing is this is decreasing. So the change in the rate of change is decreasing, in other words, going down and to the right, at an increasing rate. That's the part that means concave up. So it's decreasing at an increasing rate, going down, concave up. Okay, if I were to answer this one, you would say that's increasing at a decreasing rate because it's increasing on concave down. So it all is dependent on what you're talking about. But in this case, that's that. So 3 here had 4 parts. So I would like to imagine that the way it's graded is probably dependent on you showing work or you explaining, or the fact that we had to do 5 points on the one part. But yeah, that's 3. So that's free response question number 3. No calculators, lots of science stuff. Expect to see something like that. Like I said, in almost every single free response practice problem, I ran into this picture right here. Almost every single one, you run into this picture. Does that mean you're going to run into the same exact problem? No, but I would bet some money that you're going to be given some type of oscillating thing that maybe goes around in a circle or goes back and forth, and you can answer questions that we just saw. So be ready for something like that. Okay? That was fun. Hope this helps.